So this is chapter 7 of C4. You need to be good at your integrating because that's what's going to be involved here. So we've just come to this chapter from the integrating chapter. But let's look at these words first of all. What's an equation? An equation is something that contains an equal sign. Okay, what's a differential? Well, as far as we're concerned, a differential is something that contains a dy dx. I mean, it could be other letters than x and y. So a differential equation is, pretty unsurprisingly, something that contains a dy dx and an equal sign. That is what a differential equation is. The most simple differential equation, and the simplest, is going to be dy dx equals 1. That is a differential equation. And if we are trying to solve it, what they mean by solving means remove any dy dx bits, and you're often, but not always, you're often looking to get it as y equals something. And how do you move from dy dx to y? You integrate, yes. Okay. So to get from there to there, the process of answering these questions is through integrating. Okay. So I'm going to write that equation down again. The way we generally do it is through a technique called separating the variables. And separating the variables means you separate the x bits from the y bits. So what it means is you have all the x bits on one side of the equal sign, and you have all the y bits on the other side of the equal sign. So it's just a case of rearranging your equation. So we will call this example number 1. So if I separate those out, so I dot x bits on one side and y bits on the other side, what is the easiest way to do that here?
What times it by dx?
Yeah, shift that dx over there, times it by dx. So the left is just dy, the right, 1 is there, and the dx goes there and multiplies. So this separating the variables, that is like step 1, and step 2 is you then integrate both sides. So literally what you do now is you write down what you've got and you stick an integral sign in front of both sides. Now, what do you get when you integrate dy? And if you want to think, well hang on, integrate dy, I don't know, you can write a 1 in there. What do you get when you integrate 1 with respect to y? Y, yeah. What do you get when you integrate 1 with respect to x? When you are integrating, what should you always write down? And that is the general solution. That is called the general solution to that differential equation. It's called a general solution because of that bit there. Because it contains a plus c, because we don't know what that value of c is, that is called a general solution. Sometimes you're asked to move from a general solution to what is called a specific solution. And to find a specific solution, that is saying, and find out what C is, well, you would need some other information to do that. For example, if you were also told that y equaled 8 when x equals 5, what can you now tell me about C? Yeah, it's just substituting in. I have y equals x plus c. That would tell you that c would equal 3. So that would give me the solution y equals x plus 3. And that would be my specific solution. That did not have a plus c in it. So you need some other information to get from your general solution to your specific solution. So that's the most simple example. Are we happy with that one? Okay, right, let's plough on now. So, next one. Number 2 is solving dy dx equals log of x. We're told that x is always going to be greater than 0. Why are they saying that?
So you can do 1 over x.
So you can do 1 over x, and so you can do log of x as well. Yeah, you're on the right lines. And they're also telling us if y equals 2 when x equals 1. And that other bit of information means that we can get a specific solution, not just a general solution. So, first thing to do, write down the equation. Okay, what's the next thing then? What was our first move on that last one?
X is on one side.
Yeah, okay. Separate the variables. Okay, so if we separate the variables, keep the dy where it is, keep the log x where it is, move the dx. It's dividing on one side, timesing on the other side, and then what was my second step? What was next after separating the variables?
Integral sign.
And the integrate, yeah. Okay, so I'm now integrating both sides. What is it useful to write if there's nothing between the integral sign and the dy or dx bit? Useful to write in there a 1. Okay, so integrate 1 with respect to y, we get y. Integrate log x with respect to x. Can you remember the result I suggested you remember when we did integration by parts? It's a useful one to remember, saves you an awful lot of work.
X, X.
That's part of it.
Minus s.
Well done, yeah. That was that result, okay? That was one we learnt, or I suggested you learn when we did integration by parts. It comes in to be quite useful. Okay, x log of x minus x. I finished my integrating. What else do I need to write down now?
Plus c.
Plus c. And that line there is my general solution. I've got rid of the dy dx's. It's got a plus c in it, so that's my general solution. So I need to move to my specific solution. I was told this thing over here. So I'm going to write that down as I'm going to use the coordinate point 1, 2. When y is 2, x is 1. And just substitute that in. So y equals x log x minus x plus c. Right. What is log 1? 0. So that bit there is 0. So I get 2 equals 0 minus 1 plus c. So what must c be? What do you take 1 away from to get an answer of 2?
3.
Yeah, okay. So c must be equal to 3. So you rewrite your general solution where you change the c into the number, and that solution is called the specific solution. And when you have that, you've got the question answered. Okay? Are you okay with that? Right, another one coming up then. Number 3. Solve x dy dx equals minus tan y. If y equals pi by 3 when x equals 2, and we've got to solve it in the form x sine y equals k. So we've got a differential equation, that's the first line. We've got a condition, which means we can move from a general to a specific solution, but they want it to be written down in a certain way. Okay? So they want it to be written in a certain way. We're going to have to deal with that bit at the end. Okay? So, first thing, write down what we've got and what is step 1.
Get them all on one side.
Get them all on one side. Right, now, have a little think. What you don't want is the dy bits or the dx bits to be on the bottom of fractions. You want the dx bits and the dy bits to be on the top lines of things. So, keep the dy where it is. That's on the top. Keep the dy where it is, which means you are going to have y's on the left. So that minus tan y needs to come over here and become a dividing. So you'll move the dx, which is on the bottom of a fraction here, to the other side where it becomes a multiplying. And then you've got to move this x from the top here to the bottom of the other side. Okay. And then, when you've separated the variables, which we've just done here, the next step is to integrate. Right, let's just see, can we tidy this up over here? First of all, on the right, it might be easier to write that as 1 over x dx. Now, over here, I'm going to put my dy there. I've got over here 1 over tan y, and I've got a minus sign, and I'm integrating that. Can you integrate 1 over tan easily? And taking the silence means no. What is tan the same as? Sine over cos. So what is 1 over tan the same as?
Cos over sine.
Cos over sine. Okay? Because tan was sine over cos, 1 over tan must be cos over sine. What have I left out at the moment that I mustn't forget?
Negative.
Yeah, that minus sign. I'll just bring it out here. Now, can you integrate what's on the left of the equals or what's on the right of the equals easily?
Right-hand side.
On the right hand side. Okay, what do you get if you integrate the right hand side?
ln x.
That's correct, yeah. I'll put my plus c in there. Yeah, integral of 1 over x is log x ln x. Here, you're integrating a fraction. Think back to what we have done.
Sine is cos.
The differential of sine is cos. That is a function on the bottom with its own derivative on the top. Okay, actually they're y's, not x's here, but you know the rule. So when we are integrating that, what have we said we get?
ln of that.
Yeah, we get log of the function on the bottom. So here we actually were able to write it down when the top was the derivative of the bottom. That red box rule there tells us that we get log of f of x. So if I integrate this thing here, I'm going to get log of sine y. The minus sign I mustn't forget, and over here I'm going to get log of x plus c. Now, that is really a general solution, because I've got no dy dx's in there anymore. So if that's my general solution, What's been my next step after a general solution? To find the specific, so I need to substitute some stuff in. In the question, it told me that when x is 2, y was pi by 3. So that's the coordinate point that I'm now going to use. Okay? So if I substitute that in, I'm going to get minus log of sine y equals log of x plus c. What do you think it would be a good idea to do next? What are we trying to find now?
C.
Trying to find c. So what should we do next? Yeah, bring that over here. So I've got minus log of sine pi by 3. That log of 2 becomes a minus log of 2, and that's equal to c. Right, now what? Is there any way a calculator can help us out here? Hopefully. What's sine of pi by 3? Put sine pi by 3 in your calculator. What do you get for sine of pi by 3?
Root 3 over 2.
Root 3 over 2. Okay, so that bit there is root 3 over 2. Okay. Think of laws of logs. We've got here log of something over something. We've got here log of a over b. You should know a different way of writing that. Log of a minus log of b. Okay, good. So lots of things from your past are coming together here. So this thing here, I'm going to put that minus sign down, and then I'm going to do this to that. So that's log of root 3 minus log of 2. That minus sign applies to the whole bit there. Then I've got minus log of 2 equals c. Yeah, so I've got here, I will just write it out full. I've got minus log root 3 minus minus, which makes plus log 2, minus log 2 equals c. The plus log 2, the minus log 2 cancel out. C is minus log root 3. So I can now replace my c. So ages ago, at the top of this bit of paper, I had a general solution, and I'm now going to rewrite that general solution, but my c is that. So I'm now coming on to my specific solution, which is minus log sine y equals log x minus log root 3. Now the question said I had to write my answer. I am aiming to write it in the form x sine y equals k.
Everything's got a log in it.
Everything's got a log in it. So what should you try to do? Because this has got no logs in it. What do I need to do at some point? Get rid of the logs. Yeah, no, I mean, you need to get rid of the logs. How do you get rid of logs? What kills a log? What's the opposite of a log? E. Okay. Now, if you're going to get rid of all the logs, you need all the logs on the same side of the equal sign. Okay? So, what I'm going to do now is, well, most of them are over here, so I'm going to leave those where they are. I'm going to move this to the other side, where it will become not negative, but it will become positive. And that's now equal to 0 on the left. Now, we can use those laws of logs again, like that one we wrote down up there. This is log of something minus log of something plus log of something. Go sort of backwards on that one. What can you do? You can combine those into one big log thing. What will it be? What bits are you adding? Starting with that bit that's positive, you're adding that bit. If you're adding them, what will you do in this big bracket thing here?
X sine y.
Yes, you will multiply them. If you're taking away, what will you do in here? Divide, yes. So I've now got that. Now, we've gone on a long way, but we are nearly there at the end of this question. I now have log written down only once. What did we say removes log? E. So now I need to do E to the left hand side, and I need to do E to the right hand side. So on the left hand side I will have E to the 0. On the right hand side I'll have E to the log of x sine y over root 3. What is E to the 0?
1.
What happens over here?
E and ln cancel.
And you are left then with x sine y over root 3. We are aiming for x sine y equals some number. What have I got to do now? Yeah, get rid of root 3 up here. There we go. I've got x sine y equals some number. If they wanted to know what the number was, well, k is that root 3. It's another example of these questions in C4 bringing lots of things together from lots of different areas.